Ants are eusocial species in that they collectively operate at the highest level of organization. The colony work together as a unit. Their tasks are allocated and interdependent. According to research by Deborah Gordon of Stanford University, such tasks include patrolling, foraging, brood care, and nest maintenance. She has found that inside the nest of harvester ants, duties include brood care, food, storage, and nest maintenance. Outside, however, she discovered that ants forage for food and patrol area assessing for food resources. Among the many tasks allocated by the colony, foraging is the most interesting behavior as it is observed by very distinct trails. How did this behavior come about? In an attempt to fully understand this behavior, we must utilize Tinbergen's four levels of analysis: causation, development, function, and evolution. In observation, the ant trails appeared most distinct when there was an abundant food source. Therefore, it is hypothesized that foraging behavior is stimulated by the presence of food. According to an article written by Sheffer, Holmes, and Gordon in 2006, forager activation is stimulated by an abundant food source. In their investigation, the rate in which foragers returned to the nest was linked to food availability. In turn, this behavior influenced the rate that inactive foragers left the nest to return food back to the colony. They found the success of foraging behavior only applicable if there was an abundant food source. In the area of development, I hypothesized that foraging behavior is an innate behavior. In an article written by Trippett and Nonak in 2004, they discovered that foraging behavior is both age dependent and influenced by task needs of the colony. They found that older ants were more prone to foraging because it is a more dangerous task, whereas younger ants were more biased towards brood care. However, they also discovered that foraging behavior is influenced on a need basis. Among a nest of isolated foragers, they found some foraging for food while others tending to tasks that needed to be done. This explains that foraging behavior is more of an innate process, but can also be learned based on the experience of ants. On the functional analysis of foraging, it is hypothesized that foraging behavior is a survival strategy in which ants lay a pheromone trail that results in the recruitment of other ants to a specific location. Researchers Plaus, Johnson, and Holleboy revealed a linear relationship between the number of ants that left the nest to the amount of pheromone deposited in 2012. This particular foraging strategy led ants to a specific food source in which reduced the risk of being lost or disoriented. On an evolutionary basis, I hypothesized that foraging for food is an adaptive behavior as distinct foraging trails are observed among every ant species, leading to the overall fitness of colony survival. An article written by Farji Burner and others suggests that head-on encounters between leaf-cutting ant workers facilitate information transfer about food resources. Therefore, large density of ants impose congestion that results in head-on encounters, which ultimately increase the foraging efficiency of ant colonies.